Okay, good morning, everyone, and please forgive me, it's a little bit early for me. I just woke up and maybe not very coherent. So I will be talking about two very popular HDF5 features that were requested, by the way, and supported by synchrotron community. It is HDF5 SWMR and file versioning features. I believe I first time talk about them in our first European HUG that was in Grenoble. I believe it was in 2019. And then at that time, the features were one in just on paper, in design, another one was a very quickly put prototype. So now they are, so now I need to figure out how I move my screen. Okay, I'm on the right slide. Sorry about this. So, so those features are available now in much more mature prototypes, and single writer multiple reader access to HDF5 files that we call VFD SWMR is a full reimplementation of current SWMR that has a full set of features that and addresses the deficiencies of the SWMR. Current SWMR. It is available in the feature branch. There are actually two branches. And HDF5 file provenance in the revision version control feature, also called Onion VFD, was released in 1.14.0, but they're still in prototype state. Even very well mature prototype that is working, compiling, but there are some features missing, and I will talk about this. So the reason I'm giving this talk, because we know that those features are very important for you, and we need your feedback on both features to finish productization. So Lifeboat was lucky to get funding to develop a recovery tool for files when application crash, to develop recovery tool to recover data from the corrupted file. And that work is based on HDF5 VFD SWMR. So we will be working closely with HDF group developers to bring new implementation of VFD SWMR to full production and deliver the tool also to recover data from corrupted file. So that work was funded by the Department of Energy, DOE. It is a small business administration program. We received phase 1, and we have, of course, grandiose plans for phase 2 if we're awarded. So first, I will talk about VFD SWMR and hope my demo will work in the so early in the morning. New VFD SWMR, as I said, addresses deficiencies of the current single writer multiple reader SWMR. So as you recall, SWMR was first introduced in HDF5 1.10, and it has implementation has a lot of limitations. And first, the biggest limitation is that it's based on POSIX semantics, and specifically it is based on requiring not even atomics, because, for example, atomics, you cannot guarantee atomics on Lustre system. It requires preservation of ordering. For example, if you have writer A and writer B, then when writer A finishes and the writer data written by writer A should become visible to the readers before writer B before writer B finishes or puts the data. So the order of writing is very important. They see A, readers see A, and then they see B. So as a result, we couldn't support SWMR on file systems that do not have this requirements. And there was no support for NSF, and Michael talked about it, how they bypassed the problem. Also, there was no, we couldn't allow modification to file structure. So the programming model is writer has to create the structure of the file, then reopen the file in the SWMR mode, and only raw data would be able to be added to the data sets. There were no creation of groups, data sets, and attributes. There was no support fee for variable length data types, and so on. And another several important restrictions that new data was not visible for some time, and to make it happen, application has to flush even the whole file, which is very expensive operation. There was no support for parallel application, and order of writer and the reader was critical, so reader couldn't come before writer. So new implementation removes all these limitations, and with the new implementation, and I will show you in my demo that it allows modification of a file structure. What is very important, it is almost near real-time model now. We guarantee maximum time for new data visibility and no POSIX semantics required at all. So we can support this new single writer, multiple reader access on NFS systems and on object store. And we really can use any drivers underneath VFD SWMR to access any kind of storage, so taking advantage of underlying storage. Also, we lifted the requirement for writer and reader ordering. I will show you that reader come first and wait until writer starts writing. And after tomorrow, I will be talking about projects Lifeboat works on that will support new storage for variable length types. Current implementation, until that storage is implemented, will not work, but as soon as we have new storage for variable length types, SWMR will also support variable length data types. And as I said, we will support parallel applications, and we will have a tool to recover corrupted HDF5 file. In the future, we also hope to improve HDF5 architecture to simplify maintenance, remove complex flush dependencies that are now in the metadata cache, which is very hard to maintain, and we have to be very careful when we maintain HDF5 library. So if you want to look at new design, there is like 78 pages RFC with detailed design. It is in the repo. I'll show you after I switch from slides to my screen where it resides. And it is much easier in some sense to use in terms of programming. You just need to know several implementation concepts and requirements. And one of the implementation concepts is based on notion of tick that describes periods of operations for both writer and reader. And tick depends, of course, on latency of your system, but you know the latency of your system, and you can specify for applications that I want to see my data within this latency. And tick is defined being 1/3 of this period of time, and it is measured in 1/10 of a second. So, for example, in our examples, you will see tick of equals to 4, meaning it's 400 milliseconds. So another concept of new SWMR implementation, it creates HDF5 metadata file, because observation is that in HDF5 library, when application enters most of HDF5 calls, the ones that do not use callbacks, metadata in metadata cache that was the cause of all these flush dependencies and complex implementation, metadata cache was not in consistent state, and we know when metadata cache is in consistent case, and we can flush metadata to the page buffer that application has to use at the end of each tick and keep track of modified metadata pages. Metadata pages then written to storage to a metadata file, and how metadata file is implemented and where it is stored, it is up to the user, it is controlled. And RFC describes, for example, on NSF implementation of metadata file will be slightly different than it is on Linux, but it is on HDF5 side to implement that metadata file. And metadata file stores updated metadata pages of metadata, and it stores them for maximum lag ticks that once again under user control how big this metadata file should be, and metadata file is shared between writer and reader, and then reader always satisfies requests from the metadata file that sits somewhere on the file system and can be on some fast device and so on. This slide kind of summarizes the architecture of the new solution. So VFD writer just uses regular POSIX IO VFD for now, but in the future it will be able to use any driver here. HDF5 library, every tick, it creates snapshots of metadata and writes it to metadata file that contains also index and that is stored in the file. On the reader side, there is this VFD SWMR that sits on top of a POSIX driver, and all metadata reads are served from metadata file, while POSIX, if metadata is fresh enough, so it didn't make to the file, but POSIX driver goes down and reads raw data from HDF5 file. And when metadata is available in HDF5 file, reader can satisfy that request and drivers can satisfy this request from the HDF5 file. So this works really beautifully. And programming model is very simple. On the writer side, writer has to use special creation property and access properties. And creation property is to specify paged allocation, because remember, we are flashing metadata pages. That page allocation is used only, strategy is used only for paging metadata. And access properties, we advise you to use right now latest file format 114. You just specify the latest with setlib bounds. We simply didn't have time to test if it works with 110. It should, but it's not tested. And then enable page buffering, so set page buffer for a specific site, and configure a SWMR with the parameters that I already talked about. So what the difference between configuring reader and writer will be the field of config writer for writer will be set to true, and for reader it's state false. And you configure VFD SWMR as usually with property, special property call with this API call, and file is created with those creation properties and access properties, or just open with access properties. So on the reader side, we just need to set access properties and specify location of the metadata file. As you see now, we have some kind of deficiency here. A reader has to know settings of the writer, but this is not a showstopper, because under other project we are working on providing dynamic configurations, configurations that are done through the configuration file for the stack of loadable VFDs. So this information can be shared through configuration file in the file system. So reader opens with this configuration and it checks when metadata file is available. If it's available already, because writer started, it will start reading data from the file, and data is available at the length of user-specified latency. So now I hope my demo will work. So code is available in this new SWMR implementation, is available in GitHub repo in feature branch, and there is another branch, VFD SWMR. This is probably latest, but word of caution: while code builds and tests pass in default mode, there are a few tests that fail when we do more rigorous testing with special setting of the testing parameter. So we are working on this. There is also the doc directory under VFD SWMR documentation with the VFD SWMR user guide MD file for building instructions, and it provides extensible dataset example that works really like current SWMR model when file is pre-created and then data only added to the file. I will show you different demo that you can find in README in examples directory. It is the it is the program that creates and deletes data sets and adds attributes, and I will be using H5LS tool, modified H5LS tool, to pull the data and display the content of the data while that program is running. Unfortunately, those examples are you will need to do some modifications. If you need diffs, I can send it to you, but we will fix the repo, so those examples will also compile. On my slides, you will find the configuration of SWMR settings. And now this is demo. I need to find how I disabled. I will stop share first. Now I will stop my screen. Just a second. And I lost my Zoom. Here is my Zoom. I will share once again, and now I will share another desktop. Which desk? Do you see the screen with VFD SWMR user guide? Hello?
Yes, we see that. We see your browser. Welcome to VFD SWMR.
Okay, I'm sorry. I thought I lost everyone. Okay, so here I have 3 windows open. Just a second, I will move it.
Yeah, we are working a bit on bringing it to the screen in the seminar room.
Okay, so you see 3 terminal windows, right?
Yes,
in principle,
exactly.
yeah.
Okay. So this window, and you see my mouse. So this window is this example that was compiled as usually with H5CC. In this window, I prepared the command for the H5LS that comes with distribution and installed in my other directory. And I'm using special option here to pull every 100 milliseconds, I believe, and displaying the content of the file. And in this, I'm in the same directory where my program will run, because metadata file will be created in the same directory. So let's first start. I told you that I can start reader first, so I'm starting, H5LS tool. Nothing happens, of course, because there is no metadata file. Here there is no metadata file. And now I will start creating the program that creates and deletes data sets. And it runs, and now in this window you see the data that coming from H5LS. And here I can repeat my command. Oops, I'm probably in the wrong directory. Why it's not showing? Okay, it's demo. Oh, here it is. Here's the file. Why? Okay, so empty. So what I'm doing? Oh, my MD file. Okay, so it is the file is my MD file. So you see my MD file. So we're good. And you see the file will stay the same size, because I'm recycling, application is recycling metadata pages that are stored in the file and are served. And this is, poor guy, it just simply, it just stopped. Not stopped, it just cannot deal with the output. So now I can safely do Control-C here. and this stops H5LS will pull the same data. It pulls the same data. And you can see that now MD file, the program deletes it. The library deletes it when it exits. This is still can read the file, and I can interrupt this. And what I can do, I can just do another command. I can do H5 dump, and you will see the same last data sets and groups in the file. So this is that was my demo. Now go back to the slides. I can probably. Do I still have time, or I'm staying between you and lunch? May I continue?
I think we can give it another 5 minutes.
Okay. The thing is, there will be. So let me. Can you see my? Okay. Now, which slides do you see now? Which?
Actually, the wrong one. So if you swap.
Yep.
Yeah.
Okay, so in the afternoon we'll have a talk from Baptiste Gautier about how this feature HDF5 provenance is used in the use in non-destructive testing. I just want to remind that this feature exists and looks like it becomes even more important for nowadays applications. And it was triggered by the user's request that users wanted to track changes in the file and have undo capability, for example, for HDF view. And nowadays, that tracking of provenance and history of changes in HDF5 file becomes even more important for AI and ML applications, because there are a lot of applications and frameworks like Keras, TensorFlow, PyTorch that store model checkpoints and serialization. Large data sets are stored in HDF5 for training purposes. Those training data sets are stored in HDF5, and intermediate data storage for preprocessed data like model state and optimizer states to resume training session are stored in HDF5. That's why having provenance in HDF5 is very important. So feature was released in 1.14.0, and it implements one of those three scenarios that all have their benefits and their downsizes. So the idea is that a logical HDF5 file is divided into logical pages, and when Onion VFD opens, when file is open for tracking the changes, modified pages are stored at the end of the between close, open and close. Those modified pages are stored at the end of the file with the corresponding index. And this is the picture, that is the first picture. The advantage of this approach is that you always have one file with all history, with all annotations and so on. Unfortunately, this is not implemented. What was implemented is the second scenario when you have Onion file that have, for each version has modified pages and index how to find those pages. In library, when opens the file, it opens also Onion file and then finds pages modified for specific version. And there is the third version when each modification is stored in simple file, which is much faster in terms of access, but you have a lot of files in the file system. So the question for audience and for HDF5 users, what kind of performance issues you're having if you're using it, what you want to see in terms of performance, and it's not only I/O speed, but also storage requirements, because right now modified pages are stored as they are. If you modify 1 byte in this logical page, that all logical page with just 1 byte will be stored instead of storing just modified byte and location of this byte. That's why your input is very important for us to understand what will be priorities, where we should get development of Onion VFD further and release it in more mature state. So thank you so much, and you can find all information on my slides.
So thank you. So are there any questions? Yeah, there's one.
Hello, Elena. Good morning.
Good morning.
Thank you for your presentation. One question about the swimmer functionality. I see the concept of max latency that it's, and the concept of tick. Touching latency, I can understand what I could get from reader point of view. But what would be the effect with tick respect the way of behavior now? What could I get if I modify this parameter? What effect should I see?
It is just guaranteed interval when the reader will see new data. So we tick is the tick. We set it to 1/3 because in the library we can flush as quickly as we can flush the metadata pages at this frequency. And if you define as interval t, then within interval t of your latency, we have 3 intervals for us to flash the data. So some new metadata will definitely make to the system.
Which is different to max latency in that case.
No, you specify t, interval of t is how quickly you want to see the data. You cannot see the data quicker than latency of your system, right? So the t should be at least equal or greater to that parameter.
Okay, thank you.
But we guarantee that that's why we flush metadata pages every 1/3 of the tick. So we're doing it faster than commitment for the system to show new data.
Okay, thank you. Is there any other question? Okay, I don't see it. Probably everybody is looking for lunch.
Right.
So thank the speaker again.
Thank you.
Thanks, Elena, for a detailed description.
Elena, one question. The parameters, these configuration parameters that you've been working on for swimmer mode, basically, it's a way of, I suppose, to prevent problems for writer or try to prioritize writer versus readers in case that you have many readers, not to block writer, things like that? Or?
No, those parameters only to specify where metadata is stored. And I didn't have time to explain that on NFS system, metadata file is constructed from snapshots that also reside on the system. And to control when readers, what is the delay when readers see the data that written by writer. That's the only thing. And there are some other parameters like the size of the metadata file, how much page buffer can be extended to store metadata pages.
Okay.
So it has nothing to do now. There is no logs, nothing. And as you saw, reader can come first, but reader has to poll to see if metadata file exists and then start reading. But there is no logs, nothing like in the previous swimmer.
Okay.
Also, I didn't have time to mention that we're interested.
So you mean that in these snapshots, the that all involved data sets are in sync? Because in our case, for example, we have two data sets, which are the mainly ones, which are data block headers that acts like indexer, internal kind of indexer, and payload, which is just a continuous data set. And our internal criteria is that payload must be for sure there for readers when you put the data block header in the data set. So this is the order, the natural order that we have to preserve. But always we've seen that there is no internal control how to, this wouldn't help, no, to guarantee this type of synchronization between the two data sets.
Maybe we should talk offline. I don't understand, but I don't think you need it now anymore because I don't understand what you mean. I don't know what you mean by header, but you really can now work with writer and reader as regular HDF5 applications. They only need to set up, to configure swimmer, and those parameters should be the same.
Okay.
But what Rodrigo means is, let's say you record a stream of data and you have sort of a data set representing sort of the packet data, just appending packet after packet after packet. And then you would have a second data set storing offsets. That's what he calls headers, storing offsets into that packet data set. And now, of course, with SWMR, since there is no guarantee that the updates to the respective data sets will be in sync, meaning that, individually the data sets will always be in a correct state, but there is no constraint on synchronization between data sets.
Right. Right. I think, but we should probably start. Is it time to start?
No, I think we have another 6 minutes.
So let's think here, because right now you are using some delay to synchronize, right? So in this new swimmer, you can write, but then the application has to see. So what you're writing is really raw data to the data sets. And it usually comes first to the storage, and then metadata will be served from this metadata file. So I guess it should work. It may be slight delay, but you still have to poll if you have to know the state of your index, right? You need to see, but you will always have the latest. And metadata will be served. I don't think you need any synchronization. We can try.
Right, but it could be that, for example, he has written a header, meaning just a beginning and range, where the corresponding raw data hasn't quite yet arrived in that raw data set. That can happen.
There is also option to flush raw data periodically, a swimmer will automatically. Yeah, but we need to see that use case a little bit more.
And another question, in this model, now we have the possibility to know how many if there is a writer on in this moment or not in the file, or the writer has left the file,
right?
Or reader. I mean, this type of stages can be tracked now, or
yes. So a reader can track that writer start rising, and it can track that writer stop rising, because when the writer stops, metadata file is deleted from the system.
Oh, that's great, because it's one of the really points that we need.
Right, and there is no.
We've missed a lot this type of a stage to know what happened with the writer.
Right now, the prototype that sits in the branch, it definitely works on Linux systems. It also works on NFS, but it's not tested yet, and there is special way to set it up. So this is coming.
But it's taking into account the functionalities there.
Mhm.
Right. Because it's necessary many times to know if the writer has stopped or not, or
Right.
and the use the file system actions for that is not very well supported in different file systems, in different circumstances. It's really difficult for us.
Right, and you cannot rely on file size because you may be deleting and rewriting, reusing space, and so on.
Yeah.
Yeah, it's much
Nice.
more. It's simply implementation, and it's simply a concept, design concept in general.
Okay. Thank you very much.
And we're very interested, we should try those use cases because performance, we need to think about performance. It may be, initial benchmarks show that if you have more than 5-6 extendable data sets, so you're generating a lot of metadata, performance can slow down, but there are ways to improve it. So we first want to make sure that it works everywhere, and then to tune performance, and then of course have recovery tool to recover data.
Okay, thank you very much. Okay, I think we're starting in
2 minutes,
few minutes.
maybe.
Yeah.
Yeah.
Okay.